we discussed describe the motion of the molecules of the gas, uh, and we didn't discuss state and explain in terms of molecules what happens to the pressure of the gas when the means volume is reduced. And now beta, before we have to do this part, beta, before pushing the piston down, the pressure of the gas was 1.0 times 10 to the power 5 Pascal. Pushing the piston reduces the volume of the gas from 500 cubic centimeter to 240 cubic centimeter. Beta, calculate the final pressure of the gas. Okay, beta. So how would we do this, beta? Okay, beta. So this is the pressure before pushing the piston. This was the pressure. So this is, we can call it P1. Pushing the piston down reduces the volume of the gas from 500 cubic centimeter, which is V1, to 240 cubic centimeter, V2. Right, we have to calculate the final pressure. It means we have to calculate P2. Beta, the equation is P1 V1 equals P2 V2, right? So we solve it for V2. P1 is equal to 1.0 times 10 to the power 5 Pascal times V1 is 500. P2 we have to calculate, and V2 is 240, right? So beta, we will calculate P2. So it would be 1.0 times 10 to the power 5 times 500 divided by 240. Shabash beta. What will be the answer?
208.
Ji beta? Ji, what is the answer?
Sir, 208,333.3.
200
and 8,303.
208,300
3.3.
303.3 or 333.3?
Yeah,
33.3.
333.3, right? Pascal. Or beta, you can write that in standard form 345. You can write it as 2.08 जी बेटा 2.08 times 10 to the power 5 Pascal. Right beta? Okay beta? Next question beta. X and Y are liquid in glass thermometers. The scale of each thermometer starts at 0 degrees Celsius. X has large range, good linearity and high sensitivity. Y has a small range, poor linearity and low sensitivity. X and Y are liquid in glass thermometers, right? Explain beta what is meant by the difference in their ranges. Beta, you remember what is the range of the thermometer? Beta, range.
0 degrees Celsius.
Beta, range of the thermometer is basically the range of the temperature that the thermometer can measure. It is the difference between the maximum and minimum temperature that a thermometer can read or record, right? Or register or measure, right? So beta, if X has a greater range, it means thermometer X can cover a greater range of temperature, right? X has greater range, na?
Yes, sir.
So difference in their ranges means X has a greater range, Y has a small range. It means difference in their ranges mean X covers a greater range of X covers a greater range of temperature. Or beta, since the question says they both start at 0, and if the X has a large range, it means X can measure higher temperature. You can also write that, right? Greater range of temperature, or you can write X. G beta, you can write X can measure. G beta.
Sir, X can measure higher temperature.
G beta. X measure higher temperature, or X can measure higher temperature. Next, beta, the difference in their linearities. Beta, you remember what is the meaning of linearity? Linearity, we say a thermometer is linear if increase in length, or if the liquid expands by the same amount for each degree rise or fall in temperature, right? Or sorry, if liquid expands by the same amount for each degree rise for every degree rise in temperature, right? Right or wrong?
Yes, sir.
So beta, see the question says X has good linearity and Y has poor linearity. So the difference in their linearity means that beta, the liquid in X expands uniformly with temperature. Or you can say the liquid in X expands by the same amount for each degree rise in or fall in, for each degree rise in temperature. Or we can say liquid in X expands uniformly with rise in temperature. Okay, beta.
Okay, sir.
Now, beta, the difference in their sensitivities. You know what is the meaning of sensitivity? Sensitivity means increase in the length of the liquid per unit rise in temperature. So X has beta, X has high sensitivity and Y has low sensitivity. So beta, then what is the meaning in what is meant by the difference in their sensitivities? Beta, it means that liquid in X expands more for liquid in expands liquid in expands liquid in X expands more per unit rise in temperature. Okay, beta. जी beta, got it or not?
Yes, sir. Got it, sir.
Basic concept is same. You need to understand what do you mean by range, linearity, and sensitivity. Then the same concept, using the same concept, you have to answer. The answer is a bit like question is a bit different, a bit twisted, but the concepts are same. Okay. Better okay, a thermocouple is used to measure the temperature of a small volume of liquid. Draw and label a sketch of the arrangement. Draw and label the sketch of the arrangement. So beta, thermocouple, if you remember, we discussed beta, thermocouple consists of two wires of different materials. Okay, the ends of the wires are joined together to form junction, right? So here I'm just showing Okay, and beta, then when two junctions are at different temperature, that sets up a tiny voltage between the junction, which makes a current flow. So that's it. The voltage produced by the junction, produced between the junction, is directly proportional to the temperature difference. So beta, here what we can use a voltmeter, or you can simply just write a voltmeter, and you have to label the diagram. So beta, label the diagram. So beta, this is iron, you can take, this is one wire, and beta, this is another wire. Okay, this is copper wire. Okay, and beta, this is what you can label this. This is milli voltmeter. Okay, right, and beta, we got two junctions. One junction is kept at a steady temperature, so you can show this is melt. So beta, 0 degree Celsius, it is 0 degree Celsius. You can call this is cold. G beta, what is this called? This is cold junction. And beta, what is this called? This is called hot junction. G beta, got it or not? So this is a label diagram of the thermocouple. G beta. G beta. Beta, got it or not?
Yes, sir, got it.
Now, beta, the temperature of a liquid is changing rapidly. Explain why the thermocouple is able to respond quickly to rapid change in temperature. Beta, it's a very common type of asked question, often asked. Okay, so beta, see what makes it respond quickly to the rapidly changing temperature. Beta, it is because the junction is small and it has low mass, right? It is small and low mass, so it quickly reaches the temperature of the liquid, or it quickly reaches the temperature. All right, right or wrong?
Right, sir.
Yeah.
Junction is small and has low mass. Okay, so it quickly reaches temperature of liquid. Okay, beta. Now beta, clear? G beta, clear? Okay, now beta, we are done with this worksheet. So we're gonna discuss another worksheet. Beta, I have already shared that worksheet with you in physics OneNote. You can find the worksheet in physics OneNote. Okay, and now beta, we're gonna discuss another worksheet. Okay, beta, we had test, and actually I've I did the question of the test here, so that will also be discussed, okay? Because we had to discuss the test as well. Now, better question says, okay, a helicopter takes off from the ground and rises vertically. Okay, it then hovers at a constant height above the ground. Which sequence of energy changes takes place during the gain in height? So, beta, it's option B, chemical energy to kinetic to gravitational, right? Number two, beta, four people of equal weights on a beach use different routes to get to the top of the sea wall. Which person produces the greatest power, right? Beta, the weight of all the people is same. Like all persons have same weight, right? And they, okay, and beta, they use different routes. So beta, here in this case, basically all the people are doing work in lifting their bodies against the gravity, right? And beta, so in that case, the force needed to do the work is equal to the weight of the person, which is same for all because they all have same weight, right? And beta, the distance covered in the direction of force is basically vertical height. No matter now if someone takes slip weight or takes vertical height, the ladder, the distance covered in the direction of the force is basically this vertical height, right? Understood? So distance covered is also same. It means they all do the same work, right or wrong?
Yes,
Right
sir.
or wrong, beta? Now, beta, they all do the same work, so you have to tackle which produces greatest power. So, beta, if same work is done, but the power will be maximum if the same work is done in the least time. So here, which is 5 seconds. So it's option C. Got it, beta? Ji, beta, got it or not?
Got it.
Beta, a vehicle sinks into soft ground. The vehicle is changed so that it does not sink as far. What change is made? So beta, it's option D, the white tires. Now beta, because the tires are white, so the weight of the vehicle, which is same, if you replace the tire, weight will be same, right? Now the same weight acts over a larger area. So if area is larger, it means less pressure, so the vehicle will sink less. Right, beta?
Yes, sir.
But the next question, this is the question many students have made mistake in this question. A force is used to move an object from the Earth's surface to a greater height. Explain why the gravitational potential energy of the object increases, right? Many students have written just because the height increases. Beta, that is what the question is telling. So you don't write the same thing again and get marks for that. So beta, you have to explain. Explanation is gravitational potential energy. Gravitational potential
Sir,
energy.
gravitational energy is
mgh. Okay, so beta, as height increases, so as height increases, gravitational potential energy increases. So this was the answer. Okay, next bit of figure shows a train moving up towards the top of the mountain. The train transports 80 passengers, each of average mass 65 kilogram to a vertical height of 1600 meter. Calculate the increase in gravitational potential energy, GPE of the passengers. Total, okay, many students made mistake here. They did not take into account that there are 80 passengers, right? So beta, we know that increase in potential energy is equal to mgh, so we have to find the total increase in potential energy. So the total mass of 80 passenger is 80 times 65, value of g is 10, and height is 1600 meter. Beta, I think when you do this, you get, what answer do you get? G, beta, what answer do you get? G, beta.
sir, 832000000.
Sir, 832,
8
83
3
million
2
200.
and how many
832,
zeros?
sir,
Sir,
50.
83 million
Sir,
200.
5
4.
0. It means, beta, are there 5 zeros or 4?
Sir,
5,
50.
sir. 50.
50.
Okay, so it is 83
Sir,
million
83,200,000.
200,000 joules, right? Or you
Yes,
can
sir.
write that in the standard form as 3 and 6 and 7, or you can write it like this: 8.32 times 10 to the power
3,
7 joule.
7.
Okay, beta.
Yes, sir.
Next, beta. The engine of the train has a power of 1500 kilowatt. The time taken to reach the top of the mountain is 30 minutes. Calculate the efficiency of the engine in raising 80 passengers to 1600 meter to the top of a mountain. Right, beta? So, beta, if you remember, we have studied this formula for efficiency. Beta, efficiency is equal to energy, useful
Sir,
energy output,
energy, useful energy.
okay, over total energy input. Just to save the time, I'm just writing this E out means useful energy output, E in means total energy input multiplied by 100%, right? And beta, we also discussed another example of efficiency, that is a formula, sorry, which is P out, power output, okay, divided by power input multiplied by 100%. So beta, by the way, here we can use any of this formula, right? So beta, actually the train does work in lifting the passengers, okay, so which basically is becomes increase in their gravitational potential energy, which we have calculated here. This beta 83,200,000 joules is basically that work done by the train on the passenger, which is equal to increase in their gravitational potential energy, right? So beta, this is basically the useful energy output. This is the energy transferred into useful work by the train, right? But what is the input energy? Okay, this is given here. We are given the power of the train engine, power of the train engine's train's engine, sorry, and we are given the time. And beta, you know, using this we can calculate energy input, which will be P times T. And what is power? It's 1500 kilowatts. So we convert kilowatts into watts, so it will be basically then 1,500,000 watts, okay, times time. Time is 30 minutes and we convert that into seconds, so 30 times 60, that is into second, right? Now beta, if you do this, what answer do you get? Ji beta, what answer do you get?
Sir, you get 270000000
How many
zero.
zeros, beta?
So
Say
one,
27 and
two,
8
three,
zeros.
4, 5, 6, 7, 7 zeros, sir.
7 zeros, right? Seven
Yes, sir.
zeros, 7 zeros, so
2.7
it will be 270 millions, right?
million. Yes, sir.
I think beta, it's no, it's 2,700,000,000. Can you check it again? So there are like 150. There are 5 zeros with 15.
Ah, yes, sir.
Right?
Yes, sir. Yes, sir. It's a billion. Yeah.
Ji beta?
2.7 billion. 2.7 billion, sir.
Okay, so it's 2,700,000,000, right? Okay. So or
Yes, sir.
you can write it as 2.7 times 10 to the power 9 joules. Now beta, we calculate energy input, no energy output. So efficiency, write the formula. Efficiency is equal to E useful energy output times 100%. So beta, substitute the value. What is the value of E out? It is 3.28 times 10 to the power 7. Right or wrong? And output is 2.7 times 10 to the power 9 times 100 and percent. Okay. So beta, when you do this, what do you get?
So 3.1.
3 point. I guess you will get 3.08, right?
Yes, sir.
Right or wrong?
Or
And if you round it to two
3.081.
significant figures, you can get 3.1%. Or you can also write 3.08% if you get 3.08. So 3.08%. So that is the efficiency. Better got it or not? This was the test. Is it clear
Yes,
or not?
yes,
Yes,
sir.
sir.
Okay, so beta, I think now the time is up. So I'm going to conclude class here. Beta, rest of the worksheet, inshallah, we'll discuss in our next class. Okay, beta.
Okay, sir.
Allah Hafiz, beta.
Last, sir.
Sir.
Allah Hafiz, sir.